Okay, revision for today. Starting off, doing carbonyls. Uh, this is basically just doing what I was planning on getting done yesterday, but I wanted to get up early and do this now instead of doing it later and um, being tired. So let's start. Carbonyls are compounds with a carbon oxygen double bond. They can either be aldehydes or ketones. If the carbon oxygen bond is the end of the chain with a hydrogen attached, it's an aldehyde. The name will end in al. If the carbon oxygen is in the middle of the chain, it's a ketone and will end in one. We know this. Soluble in water. The smaller molecules are soluble in water because they can form hydrogen bonds with water. Pure carbonyls cannot hydrogen bond, but bonding is instead by permanent dipole-dipole bonding. Make sense? Reactions of carbonyls. The CO bond is polarized because the O is more electronegative than the carbon. The positive carbon atom attracts nucleophiles. In comparison to the carbon-carbon bond in alkenes, the CO bond is stronger and does not undergo addition reactions easily. This in contrast to the electrophiles. This is in contrast to the electrophiles that are attracted to the carbon-carbon. Oxidation reactions. Potassium dichromate K2Cr2O7 is an oxidizing agent that causes alcohols and aldehydes to oxidize. Primary alcohol to aldehydes, carboxylic acid. Secondary alcohol to ketones. Tertiary alcohols do not oxidize. Key point: aldehydes can be oxidized to carboxylic acids, but ketones cannot be oxidized. Oxidation of aldehydes. So reagent: potassium dichromate solution and dilute sulfuric acid. Conditions: heat under reflux. Full equation for the oxidation is 3CH3CHO Cr2SN minus plus AH plus, with the potassium being spectator. 3CH3CO2H plus 4H2O plus 2Cr3 plus ions. Okay, observation. The orange dichromate ion reduces to the green chromate ion. Yes, remembered. Aldehydes can also be oxidized using Felling's solution or Tollens reagent. These are used as tests for the presence of the aldehyde groups. Tollens reagent formed by mixing aqueous ammonia and silver nitrate. The active substance of the complex ion is silver, I don't know what that's called. Um, that ion. Conditions: heat gently. Reaction: aldehydes only are oxidized by Tollens reagent to carboxylic acid, and the silver 1 ions are reduced to silver atoms. Observation: with aldehydes, a silver mirror forms, coating the inside of the test tube. Ketones result in no change. Flowing solution containing the blue copper 2 ions. Heat gently. Aldehydes only are oxidized by filling solution into a carboxylic acid, and the copper ions are reduced to the copper 1 oxide. Observation: blue copper 2 plus ions in solution change to a red precipitate of Cu2O. Ketones do not react. Reduction of carbonyls. Lithium aluminum hydride and dry ether. Conditions: room temperature and pressure. Type of reaction: reduction. Um, Role of reagent is a reducing agent. Aldehydes will be reduced to primary alcohols. Ketones will be reduced to secondary alcohols. Reducing agents such as sodium boron hydride. Oh, it says right there. Sodium tetrahydroborate or lithium aluminum hydride will reduce carbonyls alcohols. Okay. Addition of hydrogen cyanide to carbonyls forms hydroxynitriles. Not super familiar with this. Carbonyl hydroxynitrile. HCN in presence of KCN, room temperature and pressure, mechanism nucleophilic addition. When naming hydroxynitriles, the CN becomes part of the main chain. So, interesting. 2-hydroxy 2-methyl propane nitrile, 2-hydroxy propane nitrile. Yep, makes sense. So the extra KCN increases the concentration of the CN minus ion nucleophile needed for the first step of the mechanism. Okay, I understand. So one CN for the addition, and the other is for the um, hydrogen on the hydroxide that's formed from the ketone group or aldehyde. Reactions of carbonyls with iodine in the presence of alkali. I do not remember this either. Iodine and sodium hydroxide. Warm very gently. The product CHI3 is a yellow crystalline precipitate with an antiseptic smell. Only carbonyls with a methyl group next to the CO bond will do this reaction. Ethanol is the only aldehyde that reacts. More commonly is methyl ketones. This reaction is called the iodoform test. Only carbonyls with a methyl group next to the CO bond do this reaction. Ethanol is the only aldehyde that reacts. More commonly, product CHI3 is a yellow crystalline precipitate with an antiseptic smell. Okay, iodoform test, interesting. Reaction with 2,4-dinitrophenylhydrazine R24-DNPH, or just DNP here. Uh, Reacts with both aldehydes and ketones. The product is an orange precipitate. It could be used as a test for a carbonyl group in a compound. Use 2,4-DNPH to identify the compound as a carbonyl, then to differentiate an aldehyde. Use tolerance reagent. Melting point of the crystal formed can be used to help identify which carbonyl was used. Take the melting point of orange crystals from 2D24 and then compare the melting point with known values in the database. You don't need to learn these equations for the exam. I don't really understand that. Where's the extra hydrogen coming from? Oh, it's not extra, it's moving from the NH to the oxygen. Interesting. Elimination of water. Where's the water eliminated? The OH just disappears and it forms a double bond. Where's the other hydrogen dye? Oh, in the NH, yeah. Okay, chemical reactions and optical isomers. Formation of a racemate. Racemate will be formed in a reaction mechanism where a trigonal planar reactant intermediate is approached from both sides by an attacking species. An equivalent addition of HCN to aldehydes and ketones. Unsymmetrical when a trigonal planar carbonyl is approached from both sides by the HCN attacking species. Results in the formation of a racemate. Makes sense. That's interesting. Equal chance of either forming to the racemate forms, no optical activity is seen. Okay, wonderful to know. So that's everything in the content there. So we can safely move on to the questions here. Quite a few, might not get through all of them, but I think it's doable, certainly. So I'm going to take a short hiatus and then I'll be back to answer those questions. We are 10 minutes in, so perfect time. Okay, so I really only have about 10 minutes to do this, but let's get on with the questions. So question one here. Ethanol can be oxidized by potassium dichromate to ethanoic acid in a two-step process. Ethanol, ethanoic acid. In order to ensure that the oxidation to ethanoic acid is complete, the reaction is carried out under reflux. Describe what happens when the reaction mixture is refluxed and why it's necessary. In this case, for complete oxidation to ethanoic acid. Well, it's heated constantly at a high temperature. So I'll say that. Heated constantly, I think that's an important word, at a high temperature. Because I know that it won't oxidize if it's not refluxed, so that might be able to help me get my answer, but I don't think this is something that's explicitly mentioned here. It just says the under reflux, doesn't actually explain that at any point. That's kind of a general thing. Not really sure what I need to be looking for here. I'm going to move on to B, because I am not sure what they want. Well, I'm sure I know what they want. I just don't have all the information that I need. So I'm going to leave that one. Write half equation for the overall oxidation of ethanol and water into ethanoic acid and hydrogen ions. Half equation. Oh dear. Okay, so ethanol and water. Ethanol and water. CH2 COH. Why am I drawing a... Why have we got a double bond there? That doesn't make sense. CH3 CH2OH is ethanol plus H2O goes to ethanoic acid and hydrogen ion. So what's the half equation? Yeah. So what is being oxidized and reduced to? Ethanoic acid, CH3COOH plus how many hydrogen ions? So 2 from there and another 1 from here, 3 hydrogen ions, 3H plus. Does that balance? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So you need 4 hydrogen ions. Does that make sense now? Yeah. Okay. Half equation should be well, we got minus 2 1. We got minus 1, 2 plus. B minus. minus. And this is 0. I don't know how to answer this either, so I'm just going to take the answers. Make sure it is heated to boiling point for a prolonged time. So 0 marks there. Vapor is formed which escapes the liquid mixture and change back into liquid and returns the liquid mixture. Any ethanol that initially evaporates can then be oxidized. Okay, makes sense. Heated to boiling point. Vapor forms and condenses. Ethanol that evaporates can be oxidized. Yeah, these kind of half equations is what I lose marks on in the exam, so it is just what we've written here, so that's fine. It's just plus 40 minus. That's it. That is it. Well, I don't know what I was doing there. It's the morning. But maybe I would screw that up in an exam as well, to be fair. So 0 out of 1 there. Hopefully some of these other ones will be more representative of how I can perform. C. Boiling points of the organic compounds and reaction mixture are shown in the following table. Use this data to describe how you would obtain a sample of ethanol from a mixture of these 3 compounds. How many marks is this? 5. I'm not going to do that. 5 mark I don't have time for. Use your knowledge of the structure and bonding to explain what's possible to separate ethanol in this way. Okay. Skip that as well. Let's just go into question 2 because these are kind of connected, so it'll be annoying. There's just one reason why Tom's reagent was used as an oxidizing agent in the specific test for aldehydes, rather than the less expensive acidified potassium dichromate. Acidified potassium dichromate can oxidize both ketone. No. Um, there's no observed color change when aldehydes are oxidized to carboxylic acids. That is what makes sense to me. I don't know if that's right. I think we can check that. B, C, I'm on question 2 now, so it will also oxidize. Test with alcohols. Ah, that's it. Okay, well, 0 marks on that one as well. A positive test. Alcohols. Well, we are on 0 correct right now. Carbonyl compound CH3CH2, new mechanism. Okay, this one we can do, and it's 5 marks. So mechanism is nucleophilic substitution. Was it addition? It's addition, right? Yeah. So we've got I'm just gonna draw out this skeletally. Two. What am I drawing here? This is wrong. 1, 2, 3, and then an oxygen. React slowly with HCN. Outline a mechanism for the reaction. Okay, so Cn minus, double bond, double electrons go to this. And then we get this intermediate phase where it's like, got this, and this bond breaks here. So you've got an O with a negatively charged and a electron pair, and you've got the Cn now bonded, but you just draw that as a 3 lines to the N. And then we have a KCN, or sorry, an HCN. And the bond breaks and goes to this carbon, and the hydrogen gains the electrons from the oxygen. And so that forms OH, and that forms this. Okay, you can't see this, but I'm just going to check my answer here, and then I have to go. So nucleophilic addition was correct there, so that's 1 mark. And then the mechanism is correct there, correct there, correct there, and correct for the final structure. Okay, so that's 5 out of 5 there. So missed 3, missed 1, missed 1. That's another 5. So 5 out of 10 was our final score there. So if we just switch to this, we are on 25 minutes. So I'm going to say 25 minutes there, which will be a yellow. We scored 50%, which will go yellow, and we'll go Carbonyls, which is going to be yellow, and then, oh, might do that later. Oh, no, I can't. It's the next day. Okay. Ooh. Oh, sorry, I'm not on the right window there, and I'm getting cool. Should be none. And that's, I'll keep getting spam called. There we go. That'll be all for today, all for now, and that'll be the end of the video. Okay.